So hello everyone. So today we're gonna learn about very interesting topic, which is the future of electric motors and electric generators. Um, it's presented by me and my teammate Aya Karman. And throughout the presentation, we're gonna talk about the theoretical basis of AC/DC motors and AC/DC generators. Also, we're gonna give some examples and some glance over the future. Um, so basically, first of all, what are AC motors? So AC motor is an old type that goes back to the time of AC power generation. It works in a very simple way by using the reversal of the current flow that already naturally occurs. It reverses the coil's magnetization, which consequently generates rotation in the blade. So even though outside the designed range, the motor's efficiency can get lower, it is still the best type for known loads and constant ones, as it can offer a good efficiency in most circumstances. Move on to the DC motors. The DC motors use brushes on the stator and contact on the rotor to reverse the flow of current and thereby the magnetic field. So, which drives the rotor to continue turning. So the DC motors are very simple too, and does not need controllers. They are indeed much simpler than the AC ones. In most basic tasks, it consists of two wires and it can still operate under high temperature. The brushes can be a problem since they were, and though they can be replaced, the dust that they leave can cause issues in the motor. So the DC motors are used in toys and cheaper applications since they are very simple, as we said, just two wires and a battery. And also the lifespan on in that case, like for toys and cheaper application, doesn't really matter. It's not important. Um, okay, so some real life applications for AC and DC motors. So computers. For AC motors, we can have computers, hydraulic and irrigation pumps, transportation apparatus, conveyor systems, fans, and air conditioners. Also, for the DC motors, in the medical field, we can have the sleep apnea treatment, textile rewinding machine, the textile, and DC shopper motor drive. So now move on to the generators with my teammates and friend Aya. Go ahead.
In order to have a clear idea about generators, they can easily be defined as a machine or device that is responsible for the conversion of mechanical energy to electrical energy. They are also known as dynamo. The electric generator relies on the principle of electromagnetic induction, which was discovered by famous scientist Faraday in order to execute its energy conversion task. Next slide, please. Uh, there are actually two types of generators. There are DC generators and also AC generators. For the DC generators, also known as direct current generators, it is actually a rotating machine that gives an electrical input with unidirectional voltage and flow. The essential operating principles are the same as mentioned earlier in the earlier slide. For the general definition of electric generators, the rate of change of the magnetic field across the coils as the machine revolves induces voltage in the coil. Because the coil flux increases and subsequently declines with a zero average value, the induced voltage is naturally alternating. And now moving on to alternating current generators. So mechanical energy is supplied to the AC generator through steam and gas turbines in addition to combustion engines, which is then converted to electrical energy. These generators produce alternating electrical power in the form of alternating voltage as well as the current, hence the name AC generators. Next slide, please. So in this part, we will be covering the real-life applications for AC and DC generators, as well as the technological breakthrough. So for DC generators, they can be used in mining, camping, and fields such as agriculture. As for AC generators, they are usually used in power plants and power stations in general. For the technological breakthrough, there's actually a continuous rise in the field of biotechnology, which I believe will be using an inspired version of this device, in which instead of converting mechanical energy to electrical energy or vice versa, it will be used to make conversions on the level of the energies that we have in our bodies, because the human body converts energy stored in food into work, thermal energy, and or chemical energy that is stored in the fatty tissue. So perhaps in the future we will be able to make some devices that help us increase the level of energy conversion, and perhaps help us reduce weight or some kind of a similar phenomenon. And there is also a high rise in the sustainability field, because there are examples of generators that work with solar panels and green energy. And that is all for the DC and AC generators. Thank you very much for your attention. And we would like to give a special thanks to our Professor Hassan Damawi for giving us this opportunity of researching this very interesting topic. Thank you very much.